All right, we're recording. All right, let me save this. All right, so we're going to do my stuff first, which is pretty short today, and then we're going to talk about matrices, which is a little longer. Okay. All right, so we're in section 2.4. 2.3 is on interval notation. There's a video up there on there. So we're on page 99. Okay. And when you get to 1325, you're going to be interested in intervals of increase and decrease. Okay. And they're really not that difficult of a thing. Increase means it's going up, decrease means it's going down from left to right. So anywhere a function is increasing, if I look at it from left to right, you know, it's going uphill. This is an increasing function. All right, decreasing function from left to right, you're going downhill. All right, and a constant function is just flat, right? So you get to 1325, you know, like right now, all I can do is look at a graph and you can tell me when you get to 1325, you'll have some tools to figure it out without a graph. Okay. All right, so when I look at this graph, when we talk about intervals of increase, the one thing I want you guys to get, and decrease, and constant, one thing I want you to get is we only talk about x. We don't talk about y at all. We say for what intervals of x is the function increasing. We just say for what interval, but we're talking about x. So when I look at this graph here, I can pretty much tell that it's going to turn around like here. It's going to turn around maybe ish here. All right. So if I look from point A to point B there, the graph is going up. So the graph is increasing in this interval. All right. So the interval notation, I'm going to pretend this goes down forever. So it's increasing. Now we only talk about x. So let's say this is negative 1.2 here. That's about what it is. And this goes out forever. So we say it's increasing from negative infinity to 1.2. And this is, I need to talk about it. I'm going to wait for a minute. All right. And it's also increasing from C up, right? That's where it starts turning up. So C is about what, 1.2? So I say, or from 1.2 to infinity, that thing is increasing. We're talking about x, all right? So between point B and point C, this thing is decreasing. So I'm going from negative 1.2 to 1.2. That's where it's going down, okay? Now, interval notation. A couple things. I'm going to write it here. When you want to include something, when you don't want to include something, you use a round bracket. Typically, when you have greater than or less than, all right, infinity always has a round bracket, okay? When you want to include something, it's this closed dot, we use a square bracket, okay? So the question is, like at 1.2, let's look at 1.2. So that's point C here, just right there. Is that function increasing or decreasing?
Decreasing.
I think it's decreasing. Anybody disagree? At 1.2, so we're saying right here, what's going on right here? Is it increasing or decreasing?
Increasing.
Huh?
Increasing.
Decreasing?
Increasing.
Increasing. Okay, so I have one vote decreasing, one vote increasing, right? My vote is neither, because it's changing there, right? Okay, so here's one of the, this is what's going to happen in your quiz, and that's why I want you to wait for my email, okay? Some books include that as part of the interval, and some don't, okay? I'm on this end of the fence, okay? I don't think it's increasing at 1.2 or decreasing. I think it's neither, right? It's changing. But some books will include it with a square bracket. Like that, all right? So it depends on what book you read and what professor you talk to, whether they want a square bracket or not. As a former AP calculus teacher, AP does this, but AP isn't the authority on math, all right? So different teachers do different things. And guess what I did when I did your quiz? I picked your quiz from two different books, right? One used square, one used round. So I'm going to send you directions, use square brackets, use round brackets on this problem, okay? So just be aware that, okay, don't take your quiz so you get my email. All right, so so that's what I'm trying to tell you. It's either or. Okay, so he's got a nice picture of a constant function. Constant's a flat function, right? So, all right. So that's it. All All right, so we're going to read a graph and we're going to talk about intervals of increase and decrease. So remember, the thing I want you to remember, a closed dot corresponds to a square bracket, an open dot corresponds to a round. Infinity always, always, always has a round bracket because you can never reach infinity. You don't include infinity. All right, and so this would correspond to greater than or equal this. And this would correspond to no equal. Okay. So they want us to list the intervals of increase, decrease, and constant. Remember, we are not talking about y from graphs, so y is not in the discussion. So what I do is okay, so graph starts here and it decreases until I get to there. See, I'm drawing lines down to the x-axis. So that's -5 to -2. So from -5 to -2, I know it's going down because it's decreasing. So it's decreasing from -5 to -2. Because of the closed circle, I'm going to use a square bracket. All right. Now, -2, it's changing, right? So this is one of these deals. Because of the closed circle, I'm going to put a square bracket, but I mean, it's arbitrary a little bit. All right. Are we okay with that? All right. So what happens between 2 and 4? Is it constant, increasing, or decreasing?
Constant.
Constant. So we're going to put -2 to 4. -2, I'll put a square bracket. Now 4, there's no option because there's an open circle there. I must exclude 4. I must put a round bracket. Is that all right? All right, so on the other end of this, the arrows are important. This means this goes up forever, which means x goes out forever, all right? So negative infinity is down here and infinity is up here. So the last interval, that thing is going up. It's increasing from 4 to infinity. All right, and what kind of bracket on 4? Round or square? Round, because we're excluding it. What about infinity? Round. You can never reach infinity. Infinity and negative infinity always have round brackets because you can't reach it. You can't get there. Okay. Now, there's something I wanted to tell you. 4 to infinity. Okay. Yeah, we're good. Oh, make sure when you're writing this interval notation, you always go from the smaller number or the most negative to the biggest. All right. So writing an interval, it's not appropriate to write 4 to -2. This is no good. All right. You always go from smallest to biggest. Okay. So the left one is the smaller one, the most negative, and the right one is the most positive. All right. So I remember from math that was one thing we got into. Okay, so let's look at this next one. So I see an arrow. An arrow means it goes out forever. So this graph goes down to negative infinity. And it goes up forever, so x goes up to infinity, right? So x goes all the way, all right? So my first interval is going to be from negative infinity to what? Where does it change?
-5.
-5?
Is it? I can't say.
I think I get -4. 1, 2, 3, 4.
Oh, -4.
Yeah, all right, -4. So is it increasing, decreasing, or constant?
It's decreasing.
Decreasing, all right, is it going up, down, or?
It's increasing because it's going up.
Yeah, it's increasing, right? It's going up, right? You're walking up the hill from left to right. All right, so it's increasing from negative infinity to -4. Round bracket here. On -4, I'm going to go ahead and put a square bracket just because of the closed dot. All right. Although some argument. Okay. All right, this next piece. So it's decreasing from -4 to 3. But what happens after 3?
It decreases.
It's decreasing, right? So it's decreasing even after 3. It's decreasing all the way until it turns around right here at 5. So there's an interval of decrease from there to there, right? So from -4 to all the way to 5. Round or square on 5?
Round.
Round. All right, now, after 5, what happens?
It increases.
It's increasing again. So we have another interval of increase. So the way that we write this, need a little bit of space, we put a union in between them. For the union, remember, means or. And we're going to go from 5 to infinity. Infinity is round, and And 5 is gonna be round or square?
Round.
Round, because it's an open circle. All right, there's no intervals where it's constant, right? All right, is that all right? Okay, so I'm just reading intervals on a graph. All right, we good? All right, let's go down. We got 2 more examples. I don't know why I didn't get rid of this. Let me get rid of this. All right, so somebody tell me, so it starts off and what's it doing? Increasing, decreasing?
Decrease,
Decreasing. We're gonna put arrows on there. There should be arrows. So it's decreasing. You go all the way from negative infinity to what?
-4 or 0.
Sorry, I didn't hear it.
Would it be 0 since that's the only thing on the x-axis?
Right, it's 0. It's not -4, right? We're talking x only, right? When we talk about intervals of increase, okay? There's a change right here at x equals 0, right? All right, now here's this arbitrary thing. Round or square on 0, different textbooks say different things, okay? So I'm gonna send you an email, okay? So I'm gonna put a round bracket, but putting a square bracket would be fine depending on who you're talking to, all right? And your calculus teacher will make that clear. All right, so from 0 to, and then it's going to be increasing from, right, 0 to infinity. Is that right? And not constant. Yeah, on this online class, I actually had to go research all this stuff because I had 2 kids get into a disagreement. And I went and looked it up. And I went, there's no right answer. I mean, they argue back and forth, there's no right answer, you know, and then, but the AP wants a certain thing, but they give credit for the round brackets too, so. All right, are we okay? All right, so the next one, somebody tell me the interval, the first interval, increase, decrease. What's it doing at first?
Increasing,
Increase, it's going from what to what?
-6 to 0.
Is it -6? 1, 2, 3, 4. How about -5? Okay, so from -5 to 0. Okay, what kind of bracket on -5?
Squared because of the close
Zero is going to be
Round.
or the round.
that open circle. There's no debate there. Okay, so decreasing. We're going to pick up on the other side of 0, right? And then we're just going to 5. I'm going to use square because it's closed on. There's no constant. All right, is that okay? All right, so that's all you have for me today. I mean, that's not much. We're going to go back and we're going to start looking at matrices. When you get through your first test, you'll be looking at matrices. Hopefully we'll get aligned a little better when she starts she should pick up speed at some point to get everything in. So expect that, okay? I'm just telling you, okay? All right, so we're going to go up to page where is it? We're going to talk about matrices today. We're going to talk about doing them by hand and with a calculator. Somebody asked me, I think in last period, I'm just going to make sure you guys understand, I would definitely have a calculator, okay? Because matrices are a lot easier with a calculator, but then you're going to be doing something called simplex tableau where you need a program, and then they're going to give you that, and then you need to do it for finance. So you want to make sure you do have access to a calculator. Okay, I'll just tell you, it's not like, oh, it would be nice. It's, yeah. Okay, so we're gonna go down. We're gonna do 2.4. I think it's on like page 26. Okay. Okay. So we're going to talk about matrices because after this probability stuff, you guys are going to be working with matrices, all right? Fortunately, most of the work that you're going to do with matrices is going to be in the calculator. There are a few exceptions to that. So we're going to talk about a little bit today about how to work with them by hand, all right? And then a little bit with the calculator. The thing about matrices, a matrix is just basically a table of numbers surrounded by square brackets. That's all it is. So, you know, if I just write a matrix, I'll just write one. Okay, basically what you've got is a table of numbers surrounded by two squarish kind of brackets. Now, a matrix is just a table, and they define matrices by their size. When you read across the matrix, these are called rows. Rows go across, and columns go up and down. I think about columns of a building. Oops, I spelled columns wrong. Yeah, they're columns. Columns. All right. So when you talk about matrices, one of the first things you have to do is talk about the size of the matrix. So the way that they talk about the size of this matrix, it's the number of rows by the number of columns. Columns, there, I spelled it right. All right. So the rows are the one, and the columns go up and down. So this particular matrix, how many rows does it have?
2,
And how many columns?
3.
So we call it a 2 by 3 matrix, all right? So it's the number of rows by the number of columns. Okay, so that's its size. All right, so why do we care about size? Okay, now she's gonna throw some words at you here. I'm just gonna show you by way of example, all right, rather than, okay, what she says. And it's true, when you multiply matrices, not all matrices can be multiplied, all right? Adding matrices, subtracting matrices, they're easy, okay? I'm just gonna tell you that. But multiplying, there's a specific rule that has to happen. What has to happen is the number of columns in the first one has to equal the number of rows in the second one. Now I don't have to memorize that, all right? What I do is I write the dimensions down. So basically what she's saying, if I do, let's say I have a 2 by 3 matrix, like the one I wrote up there, I'm multiplying by a 3 by 1, all right? For me to be able to multiply them, these two numbers have to be the same. Okay, the inside numbers have to be the same. If they're not the same, you can't multiply them. The outside numbers are the result. All right, so the result for this particular problem would be 2 by 1. It's the two outside numbers. Okay, so you'll know the dimensions of the answer. All right. Now, if I try to flip this problem around, if I try to multiply a 3 by 1 times a 2 by 3, can I do that?
No,
No, why not?
because the 2 inside numbers on the side.
Right, these are not the same, right? So there's no way you can do that one, okay, and get an answer, okay? So matrix multiplication is not what we call commutative. The order matters, right? A times B does not equal B times A, 99% of the time. All right, so they're not the same, but they have to be the same. All right. So so if I do, let's just do one more. If I do a 3 by 4 times a 4 by 5, can I do those?
Yes.
Yes, and what's the result?
3 by 5.
Good, 3 by 5. Okay, so if those inside numbers aren't the same, don't bother plugging them in the calculator. You're wasting your time. All right, you're gonna get an error. We'll look at that. All right. So now that we've got that, we're going to talk about how the process, all right? The process by multiplying. Now, I would not multiply these by hand unless I had variable. If you have variables in the matrix, like if you have an X in there, you can't use a calculator. You have to do it by hand, all right? So if they have variables, you must do it by hand. But, so here's the process, is you multiply the entire row, you go across the rows and down the columns, and you add them up. So what I'm going to do is I do the first row times the first column. I do A times F plus, then I do the second element, the second row, B times G plus C times H, right? So you see that I just worked across the row and down the column. I take their products and I add them up. That's the process I go through whenever I multiply. All right. So, and if you look at this matrix, what's the dimensions of this matrix? I should have done that first. How many rows?
2 by 3.
How many rows?
3 by 3.
Okay, I buy the 3. How many rows? How many things are going across here?
3, 1, 2, 3.
Here, I'll put this back in here. How many rows? That's columns,
That's columns, my bad.
right? I got 3 columns. How many rows? It's hard, it's just 1, right?
Yes,
It's 1 by 3. How about this guy? What's his dimensions? How many rows?
3 as well.
3. And how many columns?
1.
1, right? 1 column, straight up down. All right, so what I want you to see, when I multiply a 3 by 1, a 1 by 3 by 3 by 1, what's my result?
So 1 by 1.
1 by 1, so it's really just one number with brackets around it, all right? So that can happen. A 1 by 1 matrix just kind of looks like something like this. That's a 1 by 1. Okay, all right. But I want you to understand the processes go across the rows and down the columns, all right? So we're gonna, first of all, we're gonna look at a few matrices and we're gonna see if we can multiply them. We're gonna make that determination and then we'll practice multiplying. All right, so for number 1, what's the dimensions of this first guy?
2
How
by
many
2.
rows?
2 by 2,
2 by 2, 2 rows and 2 columns, right? What about this next guy?
So
2 by 3.
By 3, can I multiply them?
yes,
Yes.
Result.
2 by 3.
The result is a 2 by 3, right? Okay. So let's take a look at number 2 here. So how many rows?
2,
2 and
3,
3 columns, and I'm multiplying by a
1 by 1.
1 by
2.
2. All right, can I multiply them?
No.
No, right? The numbers aren't the same, right? Okay, can't do it. All right, what's the dimensions of this guy?
3 by 3,
3 by 3, and what about the next guy?
3 by 2.
By 2. All right, can I multiply them?
Yes,
They're the same, and the result is
3 by 2.
3 by 2, right? Okay. So that's the first thing I always check when I multiply, because if I can't multiply them, I'm not gonna plug them in the calculator. It's a waste of my time. Okay. All right, so let's get we're gonna do a couple of simple multiplications, and then I'll show you how to do a full one. So first thing, what's the dimensions of this matrix here?
1 by 3.
1 by 3, and it's times what's this guy?
3 by 1.
So the result is going to be
1 by 1.
1 by 1. It's going to be one number. All right. So we're going to go across the row and down the column. All right, and add them together. You have to remember all the time, row by column. Go across the row, down the column. So first row times the first element in the first column. So I do 3 times 5,
15.
and then I would do 4 times 1, right? And then I would do -2 times 8. Right, and I add them up, right? So let's see, 15 plus 4 minus 16, that's gonna be 19, it's gonna be 3. And I wanna put some brackets around them like that because it is a matrix. All right, it's not a number, it is a 1 by 1 matrix. All right, but you see I went across the row, down the column. All right, same thing. We're going to get a 1 by 1 across the row and down the column, right? So we're going to do 6 times -2. See, I did the first guy and the first guy, right? Then I do the second guy and the second guy. All right. So I end up with, that's negative, it end up with -4, right? Is that okay? Okay. All right, we good so far? Okay, so one more of these simple ones, and then we're going to talk about some other things. All right, so what's the dimensions of C here? What's the dimensions of this matrix?
1 by 4,
1 by 4, and we're multiplying by
a 4 by 1.
4 by 1. So we're still going to get a 1 by 1, right? So we just go cross the row, down the column. So I'm going to do 1 times 7. We cross them as you go, plus -2 times 2. Plus 3 times 0, plus -4 times -3. Okay, so we get 7 minus 4 plus 0 plus 12. I think that's going to end up being 15. Okay. So these are very, very simple examples because you're getting one-by-one matrices, and I want to show you when you don't. All right, so I will show you that today. All right, we okay with this whole process of going across the row and down the column? Okay. So normally, like I said, when you multiply, you're going to want to plug them in your calculator, and you can, it's not a problem. When they have variables in them, like you see in D and F here, you cannot plug those into a calculator. You must do them by hand, all right? Calculator cannot handle variables. All right, but we still do the same process, right? It's row times column. So when I multiply this, I'm going to take first row, first column. So I'm going to do 2b times 4b. And then I'm going to do plus, I'm going to do the second guys, negative 3a times 5c. All right, so if I multiply these together, I'm going to get 8b squared, right? And then minus 15ac. And it's a 1-by-1, so that's my matrix, okay? So I'm still just doing it across the row and down the column. You just say your calculator can't handle it, so this is the one you have to do by hand. All right, are we good? Okay, let's do this one. We're going to work across the row and down the column. So I'm going to do -1 times 4a, negative 4a, plus 2b times 5. That would be what? 10b. And we'll do plus 2 times negative 3b, so that would be negative 6b. Is that right? And the last one, we'll do 1 times 2a, which would be 2a. All right, so then we're gonna add up like terms. We can add up like terms. -4 and 2 is negative 2a. And 10b minus 6b would be 4b, and that's my resultant, right? I want to do this. I'm going to do these word problems, and I'm going to work a matrix one with you that's not just a simple 1-by-1, because I want you to see that at least once. All right, so let's look at this problem. Megan would like to figure out her final grade. She has an average of 72 for tests, 85 for projects, 80 for homework, and 75 for quizzes. Tests are 40%, projects 15%. Now, I'm hoping you can figure that grade out without a matrix, right? You would multiply the grades by the percentages, right? But they want us to set it up as a matrix. So the way that I think about this is I want to get like one answer out, one by one matrix. The result would be my grade, right? So how do I do that? I think about it, I have to do a 1-by-4 because there's 4 items times a 4-by-1 to get a 1-by-1. So that's how I know how to set it up, all right? Now, what goes where in this case doesn't really matter, okay? So we'll put the test grades, we'll put her grades first. So I want one row and 4 columns. So I'm going to set up a matrix that's 1-by-4 with her test grades and her other grades, 72, 85, 80, 75, right? That's a 1-by-4. And I'm multiplying it by a 4-by-1, so that's going to go down, right? And I want the percentages, right? I'm going to write these as decimals. So 40% would be 0.4, 15%, 0.15, 25.25, and quizzes 20. And you can verify that if you go across the row and down the column, wouldn't that give you your percentage? So you know you did it right. So we're gonna multiply those. So I do 72 times 0.4 plus 85 times 0.15 plus 80 times 0.25 plus 75 times 0.2, right? And that would be her average, right? That makes sense. All right, so I have to plug in a calculator. All right. All right, so if I plug in the calculator, I get 76.55. All right, so that would be your current course average. Okay. All right, So this next one, same kind of problem. It says the A Plus Auto Parts store had the following sales. Okay, so they sold wiper blades, cleaning fluid, and floor mats. The store sells wiper blades for $7 each, cleaning fluid for $3 each, and floor mats for $12 each. Use matrix multiplication to find the total revenue. So again, I only want one answer. I want a 1 by 1 out. I've got 3 things, right? So I have to take a 1 by 3 times a 3 by 1 to get that 1 by 1. All right, so it doesn't matter what you put in the 1 by 3. You want the number or the money. It's not gonna matter. I'll put numbers, all right. So if I put the numbers in there, it's gonna be 20, 10, and 8, right? And the 3 by 1 would be 7, 3, and 12. And that you can verify that's what's gonna give you the money, right? You would just take 20 times the money and you're good. So the result of this is going to be 20 times 7 plus 10 times 3 plus 8 times 12, right? That would be the revenue, which, you don't need matrices to figure this out. That's the thing that bugs me a little bit. But 20 times 7 is, let's see, 140. That's 96. I end up with 266. Yeah. Okay, so a little bit of math. All right, so I want to show you how to do, before I talk about calculator, I want to show you how to do one by hand. That's not as easy. It's not bad, it's not as easy, okay? So what we're going to do, actually, she has one little statement. Does she? Where'd it go? I thought she had it in here somewhere. Did she talk about it? Where'd she go? I could have swore she talked about it briefly. Interesting. It went away. All right, so am I missing something? Am I missing a page? You guys that have the notes, am I missing something or no? I could have swore, like it wasn't that long ago. All right. There's not a little statement down the bottom of the page? All right, we're going to talk about it anyways. All right. So we multiply matrices by hand. All right. Basically, what you have to remember is you're going to multiply the row by all the columns, and then the row by all the columns, and then the row, however many rows there are. So I'm going to make up a problem here. Let's do this. All right, 2 by 3. So 2 rows, 3 columns. We'll multiply that by 3 by 2. All right, first of all, I can do that, right? Because the 3's are the same. My result should be what?
2 by 2.
2 by 2. So what's going to happen when you multiply these by hand is you're going to go the first row times the first column. So let's talk, I'm going to write that over here. You're going to go the first row times the first column, and then you're going to do the first row times the second column. So you're going to do the first row times all the columns. And then for the second row, you're going to go down here, you're going to do row 2 column times the first column, and row 2 times the second column. That's basically how it works. Okay? So we're going to work this out. So the first thing we're going to do is we're going to erase that line there. We're going to do row 1 times column 1. That's be your first element. So, and let me do that in blue. So I'm going to do this row times this column. So I do 1 times 1 plus 0 times 2 plus 2 times 5. That is the first element. All right. So we've done the first row and the first column. All right. I'll do the math in a minute. Now we're going to do the first row and the second column. That's the next element. All right. So you're going to do 1 times 0 plus 0 times 4 plus 2 times 1. All right. So I did row 1, column 1, row 1, column 2. That gave me the first row. All right. Now that I'm done with row 1, I go down to row 2. All right. So row 2. Let's do row 2, column 1 now. All right. So row 2, column 1, negative 1 times 1 plus 3 times 2 plus 4 times 5. All right, so that would be that element. Got one more to go. Okay, row 2, column 2. So now I'm going to do, I need a different color, do it in yellow. We'll do row 2, column 2, like that, right? So I'm going to do -1. Can I do this lightly? No, it's not going to let me. Let's do it black. All right, -1 times what? 0 plus 3 times 4 plus 4 times 1. All right, so that's all the math that's required. Now I just got to add them up. All right, so but it's always row, column, column, row, column. You know, ever many columns, and you work across. All right, so if I add these things up, let's see. This is 1, 0, and 10. So this should be 11 for the first guy. I'm just adding up the numbers now. 0, 0, and 2 would be 2. This is what? -1 plus 6 plus 20. So that's going to be 25. And this is 0 plus 12 plus 4. I get 16. All right. So there's my result. Okay. So to multiplying is not adding and subtracting are easy. You just add the elements. But with multiplying, if you're going to do it by hand, you've got to do row, column, just go across. All right. And the only time you really want to do that is when you're given variables. All right. Now, let's talk about how to do it in the calculator. Right? We want to do it in the calculator. Okay. So there's a couple things. We have to talk about how to enter them. Enter them is the biggest pain in the neck, and then other than that, you're done. All right. So I'm going to make up a problem. We're gonna work this in the calculator. So I'm going to do. Let's see. 2 by 2. 2 by 3. All right. 4 times 2 rows, 3 columns. All right, well, we're going to put this problem in the calculator with the calculator working, okay? So we have to talk about how to enter matrices in the calculator, all right? So I'm going to pull up and she's got directions, but I'd rather just show you. All right. So whenever you work with matrices in a TI-84, Inspire similar, you're going to have to work with the matrix button. So you see the X -1, you see the word matrix right above it in blue. So that's where all my matrix stuff is. All right, so the first thing I have to do is enter the matrices. So I'm going to go to the matrix menu. So I press second and then matrix. And this is all the matrix stuff. The names is just where I call in matrices. Math is some stuff I can do with matrices. Edit is where I enter them. All right. So whenever I'm doing math with matrices, I got to enter them first. So I got to go to edit. All right. And there's all these places you can store them in. All right. Once you store a matrix in there, it stays in there until you decide to change it. So right now I've got a 2 by 2 and A that's probably not this matrix. All right. So to edit, I'm going to go over to edit and I'm going to press enter. First thing you do is you enter the dimensions. Like if this, it doesn't, there may be something there, there may not be. Just to show you, if I enter 3 by 2, it changes the size. I want a 2 by 2, right, for my matrix A. All right. And once I have the size entered, I'm going to go and press all the numbers, right? So 1, 2, 3, 4 is my matrix. So I just press 1, enter, and it just overwrites it. 2, 3, 4. Do yourself a favor and check and make sure you enter it correctly, because that's the biggest mistake people make, is they mistype something. All right, so I'm going to give people a second to get the matrix in. I see them looking down at their calculators. So. Any questions? We good with that? All right, so once you have it entered, you have to quit out of it. So the quit button is right here above the mode button. So you're going to hit second and then mode or second quit. That gets you out of that matrix. All right. Now we have to go enter the other one into matrix B. So we go back to the matrix menu. So hit second matrix. I'm going to go over to edit. And I'm going to get down to B. I'm going to put the next matrix in B. I'm going to press enter. And I'll just say that was a 3. It's a 2 by 3. So I'm going to enter the dimensions. B is a 2 by 3. So there it is. I'm going to enter the numbers. Okay, and I just do a little check, make sure I entered them right. Okay, and that's the hardest part about using the calculator is making sure you enter the numbers right. All right, we good? So now I'm gonna quit out of that, so I hit second quit. All right, now to multiply them, it's super easy. All I do is I hit back, go back to the matrix menu. I want A times B, so I do A times, and I hit second matrix, go select B, enter, and there's my result. All right, so the calculator does this all for you. All right, can I do B times A?
No.
Let's see what happens when we try it, just so it doesn't throw you off, all right? So if I try to do something that I know I can't do, so B times A, I get that, okay? Error dimension mismatch, all right? So that tells me, oh, I couldn't do it anyways, right? So don't bother wasting, when you can't do them, you can't do them, okay? All right, so that's how we enter matrices and that's how we multiply them, okay? Any questions about any of that? Okay, I'm done. You have any questions about anything you guys are doing in class? Because I actually, have some time. Everything going okay in there?
Yeah, it's just pretty straightforward, to be honest.
Okay, all right. So like I said, don't take your quiz until I send you an email about it, okay? Because there's that thing where I use 2 different books, all right? So I will send you an email. Once you get that email, you can take your quiz. Everything else is good to go, but just don't take the quiz yet. Okay, I will
Yeah.
send-
That's due Sunday night, right? At 11:59?
Everything's due Sunday at midnight for me. I make it easy, right? You got the homework on 2, 3, 2, 4, and 8, 5, right? There's a discussion forum I want you to post to, right? There's a quiz. I think that covers it, right? There's a video up on 2, 3 for you guys to watch, okay? All right, well, we're done. All right. Yeah. Chats in here. Oh, I see.